Good day and welcome to this CCSP how-to video. My name is Arjen Henselmans. I work as a cloud system engineer for Veeam, and in this video I'm going to tell you how our scale-out backup repository works, how to configure it, and what capacity and archive tier is. So, our scale-out backup repository is a backup repository that can comprise one or more extents. An extent is a standard backup repository configured in your backup infrastructure. So you can add direct attached storage repository based on Windows or Linux, or network attached storage repository based on sys and MFS, or you can add a DDoS device as an extent to a scale-out backup repository. You can add as many as you want, and this way you have one location for all backup jobs and one backup job storage location. Later on, we are going to add object storage repositories, and that can be S3 compatible, Azure Blob, IBM Cloud, and Google Cloud Object Storage to tier the backup files within our scale-out backup repository with the capacity tier. So how does this work? So we have a scale-out backup repository, SOBR. We name all those extents, we store those in the performance tier. Why do we call that performance tier? Because they sit at your local data center. They reside at your local data center. They are probably pretty fast and they don't cost you any money or transaction. So that's why we call that the performance tier. Just add as many extents as you need or as you like, and that can they can coexist with each other. So you can add direct attached storage repositories as well as NAS storage repositories as well as DDoS devices in one performance tier. So multiple extents. We then make a backup job to the scale-out backup repository, and the backup our scale-out backup repository will place those backups on each and every extent, balancing the load between all those extents. Later on, we just add capacity tier, and that's our object storage connection. So we can add S3 compatible object storage or Amazon S3, native Amazon S3, Microsoft Azure Blob, IBM Cloud Object Storage, and Google Cloud Object Storage. And then we can do a copy of the backup and or a move of backup data to the capacity tier. So let me explain that a little bit further. So we make a backup, we store that on the performance tier, one of those extents, and then we can do an immediate copy of the same data to the capacity tier. This way you can leverage 3 to 1, 3 copies, 2 different media, one offsite, and perhaps one offline, because we are able to leverage the immutability techniques of Amazon S3 or the S3 compatible devices. We can also move data to the capacity tier, and this way you can archive older backups or the oldest backups to the capacity tier when they are no longer needed on the performance tier. And of course, you can combine both options. So you can copy the backup for 3 to 1 purposes, and we can move all the backups. This all works policy-based, transparent, space efficient, so we'll only copy the data that is needed, so we don't copy duplicate data blocks to the capacity tier, and we do that with no extra cost. So Veeam won't charge you anything for the use of the capacity tier. Of course, you need to pay Microsoft Azure Blob storage cost or S3 storage cost. What are other advantages of the scale-out backup repository? That is, we are able to add extents while we grow. So with each new extent, you increase the space available in the performance tier. And when you add a new extent, we will automatically start using that new capacity without additional rebalancing of the data. So if your extents are running quite full, just add an extra extent and we start rebalancing and new jobs on the new extent. Another option to add more capacity to your scale-out backup repository is just to add an object storage there. So when you add an object storage repository in the capacity tier, and you start the offloads, the move of data, you immediately free up data on the performance tier, and this way you can leverage more backups on your performance tier. What's also an option is to retire and extend. So imagine if one of those extends needs to be retired because of old age of the hardware or other reasons, we just steal an extend. This way we don't write data anymore to that extent, but you will be able to do restores and other things. New backup jobs and existing backup jobs go to a different extent, and when the retention period has expired, you just remove that extent. This way you can really do maintenance, ease of work without copying data around or adjusting backup jobs. Of course, we use a lot of security here. So the encryption part, that's quite obvious. Please use encryption in all offloads to public cloud. And for the immutability part, when we do a backup to S3 or S3 compatible repositories that can leverage Amazon's object lock technology, we write data there, give it a flag that it's immutable, so you can't modify it or you can't delete it. And this way you will be able to always make sure you can do a restore coming from object storage in case of ransomware, for example. So how does that copy process work? Pretty straightforward. We have some Veeam backup files here, the data and the metadata in the file, and we just copy the metadata to object storage, and we copy the data chunks to object storage. We store that in our index, and this way you can always restore either from performance tier or from capacity tier, depending on the emergency that has happened. So for example, if your performance tier is deleted or is encrypted by ransomware, we can do a restore of the capacity tier. If, for example, performance tier is just deleted or is gone, or for whatever reason, we can also do a copy back of the data back to the performance tier. If the capacity tier is gone or deleted, we just copy the data again from the performance tier. Pretty straightforward. So, when we do a move, the process works a little bit similar. We copy the metadata, we copy the data chunks, and later on we do a deletion, but we keep the metadata locally in the performance tier. Why we are doing that is because we want to know which data has been moved to the capacity tier, that we don't do unnecessary reads and transactions on the capacity. That metadata is very small, so it doesn't cost you that much of storage. And of course, you can use both options at the same time. So we do a copy of data, and we do later on, when data is old enough, we move the data from the performance tier. So how does that work? We just check this box, move backups to object storage as they age out. Select an operational restore window. So how much data do you want to store locally? So what all the data do you want to move? And then we move the data. But we only move the data when it's in an inactive chain. What do I mean with an inactive chain? So when we are talking inactive Veeam backup chains, in this case we have a forward incremental backup chain with periodic full backups. As you can see, the backup of Sunday is dependent on the full backup of the first Monday in this picture. So when I did an offload of all that data, for example, Monday until Saturday, and I wanted to write a new incremental backup file, I need to read those data from object storage, especially when I start a synthetic full on Monday, because I need to copy all those blocks of data away. That's why we only move data to object storage as we call it what's an inactive chain. And in this case, what we have created a new full backup file on Monday, the old backup chain it's an old backup chain, gets moved to object storage. If you are using a reverse incremental backup, so the latest backup is always a full backup file, we only move the oldest backup files except the latest two. Because in this case, for example, on Thursday, we are going to create a new full backup file. We need to transform all the existing data to a reverse backup file. We need all those blocks of data on the performance tier. And if we need to read that from capacity tier, it would take some time and you would incur some costs about the transaction. So that's why we only do the latest two. So what about GFS style of backup? So when we do the grandfather, father, son, so the weekly, monthly, yearly backup schemes, then all backups that have a flag that is GFS flagged, so weekly, monthly, yearly, gets moved to object storage. So only the GFS only. With version 11, we introduced archive tier, so a third tier into scale-out backup repository. As you can see, we have the performance tier here. We call that the hub tier. We have the capacity tier. That's the warm tier. The spice you can use infrequent access or cool Microsoft Azure Blob cool. We still call that a warm tier here. So all backups that reside there can be moved to the archive tier. So to Amazon Glacier or to Microsoft Azure Blob archive tier. When do we move those data? We move the GFS data. Why am I telling this? Because all the data that resides in archive tier is stored for longer term there. So if you have to delete data before the expiration date, you will incur extra storage costs, and then it's not that cheap anymore. So we move data based on GFS to the archive tier. So backup data that's older than 90 days or 180 days, depending on your early retrieval settings of your archive tier. How do we do that? We do that with a temporary proxy. We spin that up in AWS or in Azure, depending on what you choose. And we move backup files, true backup files, to the archive tier. We can do that as an independent rule. You can set the check mark here. And after that, the data gets removed from capacity tier. This way you can really save on storage if you want to retain backups for a longer period of time. With Amazon, it's also possible to have a locking on the archive tier as well. So you can do a complete immutable backup from the start. So you can build an XFS repository as an extent in the performance tier with immutable, make a copy to object storage S3 with immutability, and make an export or a move to archive tier also with immutability. This way you really have from all tiers in the scale-out backup repository the option to leverage the immutability functionality. If you need to retrieve data from the archive tier, we do a retrieval request. We call the APIs of the hyperscalers, and we retrieve those data and store that in Amazon S3 or in Azure Blob, and we let it there for a couple of days. We store it there for a couple of days because if you need to retrieve backups, it costs you money and it will take time to restore data from the archive tier. And what you don't want is that, for example, if you have restored data and the customer or your internal customer is finished with the restore and the day later they need another file, then we need to run this process over again. It takes time and it costs money. So that's why we store it for a specific amount of days in the capacity tier. So how do we do that? How do we create such an backup repository? Let me show you. Here you see a Veeam backup and replication interface. You see that I already have some repositories here. We can just add that direct attached storage. I'm not going to show that in this demo, or the network attached storage, or the DDAP device, or the object storage. But if you do, please add those object storage you want to use. So the Azure Blob storage, I'm going to show you Azure Blob in this case. I already added Azure Blob and Azure Blob storage archive. As you can see, I have a blob archive here and the Azure Blob here. And then we are going to create a scale-out backup repository. So I'll go to the scale-out backup repository section here, press add scale-out, give that scale-out backup repository a name. So let me do this one, scale-out backup repository with archive. So for that, with archive. Let's add some extents here. In this case, backup repository 3 and 4. These are my local backup repositories, so this is the performance tier, as you can see. Add those. We have some options here to define, so if you press advanced, please leave the use per VM machines backup files on. That means we are creating a per VM backup file, and that means that with one single job, with multiple VMs, we can store the one VM on one extent and the other VM on another extent. And this way we can really leverage the auto balancing of all extents within the scale-out backup repository. Also, you get more performance using the per VM backup files because we use more IO streams to the backup repository. Press OK, press next. Then we have a question regarding the placement policy. We have two options available, data locality and performance. When we choose data locality, we try to store all the backup files of a specific VM that consists in a dedicated chain on the same extent. If you choose performance, we can really leverage all individual extents for each backup. So you can have a full backup of a VM on extent 1, an incremental day 2 on extent 2, and for example the incremental of day 3 on extent 4. This way we can't leverage our block cloning techniques because block cloning only works on a volume level. So VFS and XFS, if you're using that, please use data locality. And you can imagine if one of those extents is offline, we can't do restores because all the backup files in the backup chain are located on different extents. So performance, it really depends on your needs, but please always select data locality and think about the performance options here. With the next option, we are going to extend it into capacity tier. You can add the capacity tier. You can do this later on as well. So if you don't have object storage at the moment, don't do anything here. Just create a backup repository, scale-out backup repository with only local extent on the performance tier. And you can add the capacity tier later on. I'm going to do that immediately in this demo. I'm not going to do S3, I'm going to do a Microsoft Azure Blob. I want to copy my backups to storage as soon as they are created, so I want to copy backups. If you don't want to copy data in a certain period of time, for example in business hours or whatever, you can really do a permit and deny schedule here. Default, it can copy data to capacity tier the entire day. And I want to move backups that are older than 14 days. Of course, I want to encrypt my data because this will go to Microsoft Azure Blob. So I have already filled in some encryption passwords here. This is my encryption password. Just check that. Press next. And now we are going to add the archive tier. But in this case, I already added the archive tier repository and I'm going to select Azure Blob Archive. As you can see, I can't select Glacier here because there is a one-on-one relation with Glacier and S3 and Azure Archive and Azure Blob. And we only want to archive backups that are older than 90 days and that are stored for longer than 90 days there. With the storage button, we can select the check mark that we want to store archive backups as standalone files, and this way we can really make sure that all data that resides in the archive tier is an independent file that we can always restore from that backup files that are residing there. Let's just apply. Checks for some passwords. All my accounts credentials are correct. It saves the scale out backup repository. And we press finish. So now we have a third scale out backup repository with archive. Let me create a backup job. Virtual machine, feature, backup job to archive. Next, add a VM here. Let's do it quick. Just select one of those VMs, Linux 01, not that big. You select the backup repository here, get a backup repository with archive. The retention policy is 31 days, and I want to do some GFS, weeklies, monthlies for 6 months, and I want to keep 1 year. This way we can really leverage the capacity tier and the archive tier. Press next. Don't want to do any much for now, and run this job daily at this time. That's fine for now, and let me run this job now. This job will start. So I went a bit fast forward, and you can see the backup job has finished. It's written some data here. And when we go to the running jobs, you will see that there is a SOBR tiering job coming. Because I selected copy to object storage, it is going to copy this VM immediately to object storage. It takes some time, depending on your infrastructure. But as you can see, it goes pretty fast, and I just fast forwarded it, and you can see it's offloaded. So how can I check if these files are offloaded? And when we go to backups, you can find your job, backup job to archive. But you can find that on the disk. So backup job to archive is located here, and which resides on the scale out backup repository. If I go to object storage, you can see that the same backup jobs are here. Backup job to archive is located on Amazon and Microsoft Azure Blob. From here, we can do specific restore. So you can do a restore coming from object storage, instant recovery, or whatever the recovery options we would like. But we can also do that coming from the disk, of course. A fun fact to know: when we have the data available in the performance tier as well in the capacity tier, we only do a restore coming from the performance tier, because that's faster and cheaper. If the data doesn't reside in the performance tier, of course, you fetch it from the capacity tier. Let me explain a little bit more about scale-out backup repository and the seal nodes and other stuff. So I made a scale-out backup repository with blob 2 repositories in the performance tier and an archive tier. So for example, I want to seal this extent. We can do that. We just press the right mouse button, say seal, and we are going to seal that extent. We can do restores. But no new backups will be put on this extent. We also have the possibility to put an extent into maintenance mode. And when we put an extent in maintenance mode, we can't read backups. We don't write backups there, but we can evacuate backups. I can do that as well. Let me show you. Putting it into maintenance. And after it's put in maintenance, we can evacuate backups. And what then happens is that the backups on backup repository 4 gets copied, in this case to backup repository 3, because that's the only other available extent. And this way you can really copy out existing extents quick. Or you just let retention run out. That's also a possibility. If you want to add another extent, just create a new backup repository, select properties, go to the performance tier and add a different extent. Just as easy as that. Let me put this back into maintenance mode, exit the maintenance mode. Maintenance mode is also convenient for doing maintenance on the server. So for example, installing Windows updates or other things. So it's still in sealed mode, but we get it out of sealed mode. If you use an already existing repository and add that to a scale-out backup repository, we will automatically adjust all backup jobs going from the old normal repository to a scale-out backup repository. You don't have to copy data. It will be done automatically. In this way, you can really fast forward and start using scale-out backup repository. That's it for today. In the video, there are some links to our documentation and some best practices. Please read that, and thank you for watching my video regarding scale-out backup repository.